Hi friends, welcome to the Unit 4 Day 4 Example 3. Now we're getting into solving logarithmic equations. Steps to solve are over here on the side. I'm going to run through those as we do a couple different of these example problems, leaving some for me to go over in class if you're my instructor. If you're watching this video, sorry I'm not going to go through all of them. Hopefully you have a chance to be my student someday. Solve for x and check all solutions. That's an important part that we do want to check all solutions. We want to condense this into a single log, similar to the properties we talked about earlier. We can do that by saying log base 10. Ooh, I called out the base, even though there's no base written there, I called it out. It is base 10 of x times x plus 3, which we can do that is equal to 1 because they have the same base, because this is log base 10 of x and this is log base 10 of x plus 3. So now we have log base 10. I'm going to go ahead and put that 10 in there at this point of x squared plus 3x equals 1. And now what I'm going to do is I'm going to convert this to exponential form. By doing that, I'm going to establish that this is 10 times 1. Or sorry, excuse me, not 10 times 1. 10 to the first power is equal to x squared plus 3x. So now 10 to the first power is 10. So I'm going to subtract 10 on both sides. And I get 0 equals x squared plus 3x minus 10. Using the zero factor property, I get x plus 5 and x minus 2. Solving both of these. So setting them both equal to 0 and then solve, I get x equals negative 5 and x equals 2. So now I want to check to make sure that this is actually a valid solution for both of these. So you can check that by just plugging it in. If I plug in negative 5 here, log of negative 5. We talked about this a while back, but I'm just going to show you log of negative 5 gives us a non-real answer. So I know that this isn't going to work. Plus log of negative 5 plus 3. And I should get 1. So it's a non-real answer. So the only way that this works is if instead I have just 2. So now I'm going to check to make sure that this is in fact 2 plus 3 is 5. So I should end up with 1, and I in fact do end up with 1. So I know that 2 is a solution, negative 5 is not. Now this one already starts out as a singular log. I don't have any extra logs. It's good to note the base with the natural log is always e. So what I have here is e to the 36th power, but then wait a second, there's this 4 here. So there's a few extra things that we need to establish with this to kind of get it so that it's a single value. Now a lot of people will just get confused with this 4 out in front, like, do I need to convert it back? Think about, your goal is to get x by itself, so anything that you can do to make this simplified is going to be better. So what we actually want to do is divide by 4 on both sides first. This simplifies to just 1 natural log of e to the x. 36 divided by 4 is 9. And now I can do e to the 9th equals x. And that's actually simplified. E to the 9th is an irrational number. E to the 9th. You get a decimal approximation. So you are finished. If you want to plug in to make sure e to the 9th works, then 4 times natural log, 4 times natural log of e to the 9th. And I should get 36. Yep, so that does work. Number 20. Log base 3 of x cubed minus 5 equals 1. There's a singular log here, so what we can do is we can just actually convert this to exponential form right away. So this is going to be 3 to the first power is equal to x cubed minus 5. 3 to the first is 3. I'm going to subtract 3 from both sides. And I get 0 equals x cubed minus 8. X cubed minus 8 This is actually a perfect cube here, x cubed minus 8. A lot of students will want to add 8 on both sides and then take the cubed root and then go through and solve. You're welcome to do that. It doesn't notate the rest of the answers that you get for this particular one. Going back to our simplified kind of factoring that we talked about in the past, this is the same as x minus 2 times x squared plus 2x plus 4. Now, with this being said, when we simplify this, we only get when we solve this using the zero product property, we only get one real answer. You just get x equals 2. This is a non-real answer. And this actually gives us our pair of complex or imaginary answers. Going back to what we talked about earlier, whatever your highest degree or power exponent is, you need to have that many solutions. So this is the extra complex solutions. Doing this, we should end up with a value that gives this to be true. So just simplifying this, if I plug in log base 3 of 2 cubed minus 5, I should get 1, and I do. Also, you could verify 2 cubed is 8, 8 minus 5 is 3, log base 3 of 3 is 1. That's how we get that value. So that does work. For 21, what we have is we have these 2 logs here that are the same, and then we have another log that's over here also the same. So what I'm going to do is I'm just going to combine these 2 here. So this is going to give me log of, let's see, base 10 of 2x squared plus x is equal to log base 10 of x plus 8. So what I have now is I have the same logs on both sides, so you can drop the logs by raising both sides to the 10th power. A lot of students get this confused. They don't know why you can just drop logs like this when you have the same log as the base on both sides. But what you can do is raise both of these 10 to this power, 10 to this power, and by doing that, you're actually canceling out. 10 to the log base 10 cancels this out into just being 2x squared plus x. Similarly, this side is just x plus 8. I'm going to move everything over to the right-hand side. So minus x, minus 8, minus 8. So that gives me 2x squared minus 8 equals 0. Let's use the factor property. Factor out, so I have x squared minus 4 equals 0. So I get x plus 2 and x minus 2. Zero factor property tells me that I can try x equals negative 2 and x equals positive 2. I need to check both of these, see if they're in the domain. X equals negative 2 is not in the domain for the left-hand side. In fact, for both of these, I plug in negative 2. I'm taking log base 10 of a negative number, so that doesn't work. You do want to check just to make sure you did get the right thing for the right solution for the other. So I'm going to do log of 2 times 2 plus 1 plus log of 2, and that gives me 1, and then, sorry, I should be showing this, and then for the other side, log of 2 plus 8 is 10, log base 10 of 10 is 1. So that also worked, and the other one does not. Similarly, same process here with 22. I'm going to showcase this one in class as well as this one. Log 24 is the one where students usually trip up. So showcasing this one, natural log of x minus the natural log of x minus 4 equals the natural log of 5. So again, combining these. So when you're subtracting, remember you're dividing. So this is the natural log of x over x minus 4 equals the natural log of 5. So at this point I have a natural log on both sides. I'm going to raise e to both sides. E to the natural log, e to the natural log. So now I just have x over x minus 4 equals 5. So now I can multiply both sides by x minus 4. So x minus 4 and x minus 4 simplifies to 1. I get x equals 5 times x minus 4. X equals 5x minus 20. Let's add 20. Subtract x. So I get 20 equals 4x divided by 4. And I get x equals 5. Plugging 5 into each of these does give a true value because you get the natural log of 5 minus the natural log of 5 minus 4. So that's just 1. So minus 0 for here. So the natural log of 5 equals the natural log of 5. So I know that x equals 5 does work. That's all the time that I have for this video to keep it short enough. Note that I will be going over these in class, and I will see you then. Have a great day.